Welcome to Mathematics Revision, Form 3 Revision, Term 2 Midterm Exam, Section 2. So our first equation, which is number 12, reads: the table below shows the rates of taxation in a certain year, income tax. In income, Kenya pounds per year, rate of taxation in shillings per pound. In that period, Juma was earning a basic salary of 21,000 per month. In addition, he was entitled to house allowance of 9,000 per month and a personal relief of 1056 shillings per month. Calculate Juma's taxable income in Kenya pounds per year. One, we go with the formula: taxable income is equals to basic salary plus all allowances less nominal rent, if there is any in that equation. In this equation, we don't have nominal rent. So we then work out with basic salary 21,000, 9,000, which gives us a sum of 30,000. Converting them to Kenya pounds, we multiply by 12, so that we make it per annum. Then we divide by 20 to make them the Kenya pounds. That's all. Calculate net tax in paid by Juma per month. So net tax, we find where our taxable income will lie, in which band. Our taxable income lies in the band of in the 50 band. So in the 50 band, we don't have complete slab, we have remaining. So we start with calculation of the first band. The first band, which is at the rate of 2 times that 900, 7,800. 3 times that 900, 11,700. 4 times that 3,900, 15,600. 5 times 3,900, 19,500. And 7 times 2,400. That's the remaining. We get remaining by getting taxable income minus the highest value in the previous band, which 15,600. So 2,400 times 7, 16,800 as our amount in that slab. We get a total. We sum them up. We get tax due or gross tax of 71,400 per annum. That is per year. We convert this one to Kenya to monthly. We divide by 12, which gives us 59.50, and then we find net tax, which is the same as payee or sometimes income tax, equals to gross tax minus relief, which is 59.50 minus 1056, which gives us 4,894 per month. So that's all for that question, part B. Part C, Juma's thought other deductions per month were cooperative society, contribution of 2,000, loan repayment of 2,500. Calculate his net salary. Net salary, it is equals to total earnings minus total deductions. Total earnings minus total deductions. And our first deduction, so we get back to the question and see what Juma is earning. Juma is earning 21,000 and is also earning 9,000 for house allowance. Then now to find the taxable income, we include to calculate the net salary. Net salary will be equals to total earnings of 30,000 minus total deductions 2,000 for cooperative society contribution, 2,500 for loan payment, and 4,894 for payee. This one gives us a total of 93.94 shillings. Subtracting the two, we get 20,606 as the net salary for Juma. Question 13. The question 13, we have the question which is reading. In the figure above, ABC is attached to the circle center O. DOG is the diameter, and angle DGF 60, DBC 48, and angle DFE 25. Giving reasons, find the size of angles 1 FED, and let's start by finding FED. So from this diagram, we locate the angle FED. FED is this angle here. FED. So if we observe well, we are going to see that the side F, and we position it well. FBDE is a cyclic quadrilateral. FBDE is cyclic quadrilateral, and we know that opposite angles of cyclic quadrilateral add up to 180. So one of the opposite side of this quadrilateral, that's the quadrilateral G. It is G, D, EF. GDEF is a cyclic quadrilateral. GDEF. Opposite angles. This angle is 60. Opposite will be 180 minus 60. So angle FED is equal to 180 minus 60, which gives us 120. And the reason is opposite angles of cyclic quadrilateral add up to 180 degrees. Our next angle is obtuse angle FOB. Let's locate the angle FOB. FOB. We want this angle FOB. If you have a look at this one, the code FB is subtending. The code FB is subtending angle E at the circumference, and angle FOB at the center. Angle at the center is twice angle at the circumference. So let's find the angle at the circumference. Angle at the circumference will be, if this angle is 48, and it is the angle between the tangent and the chord BD, so the same chord is subtending angle 48 at the circumference. So this angle will be 48. This one will be 48. Now from 120, we subtract angle 48. This angle here becomes 72. With angle 72 at the circumference, so the angle at the center will be twice. So the angle at the center, which is obtuse angle FOB, will be 72 times 2, which gives us 144 degrees. Reason being, angle at the center is twice angle subtended by the same chord at the circumference. Part E, EBD. Angle EBD. Let's locate angle EBD. EBD. Consider the chord DE. Chord DE is subtending angle B at the circumference, angle EBD, which is 25 degrees. It is also subtending angle EF. Since EFD is 25, also angle EBD will be 25. So EBD is equals to angle EFD. This equals to 25 degrees. So angle EBD is 25 degrees. Why? Angle subtended by the same chord DE at the circumference in the same segment are equal. Angle BCD. BCD, it is equals to, let's locate the angle BCD in the diagram. BCD. BCD. Angle BCD is we have 48, then we have 25. If this one is 25 and this one is 48, and then we consider triangle EBD, angles in the anterior angles of a triangle will add up to 180 degrees. So 180 minus this angle here would be 180 minus 48 plus 25, and this one gives us 107. Angles on a straight line add up to 180. 180 minus 107, this one is 73 degrees. So 73 degrees. So the now angle BCD will be the sum of interior angles of a triangle will add up to 180. 180 minus 48 plus 20 plus 73. So 48 plus 73. This one is 73 plus 48. So angle BCD becomes 180 minus 73 plus 48. This one gives us 59 degrees. Reason being, sum of interior angles of a triangle add up to 180 degrees. Angle OBE. Angle OBE. Let's locate angle OBE. Angle OBE. O, B, then E. OBE. We want this angle here. Angle OBE. So we know that angles subtended by the chord being the diameter is equal to 90 degrees. So the whole of this angle will be 90 degrees. If we had this angle as 144, the base angles would be equals to, and this one is 60, this one would be 84. 180 minus 84, then we divide by 2, we get 96. Divided by 2, we have 48, and then 48. After we have subtracted 60 from 144, we get 84. Base angles of isosceles triangle GOB will be 48. So it leaves us with this one angle here. So this angle will be equals to 90, angle subtended by the circumference at the circumference by a diameter, minus 48 plus 25. These angles here, 25 and 48, we are looking for this angle, which finally gives us 17. So what will be the reason? Angle, how did you get this 90? The angle subtended by diameter being the chord is 90 degrees. Angle subtended by the circumference by the diameter at the circumference by the diameter being the chord is 90 degrees. And that's the argument for question 13. Now question 14, we have question 14, we have a triangle which has also other two triangles. So the question reads, in the figure below, not drawn to scale, AB 8 centimeters, BC, AC 6 centimeters, AD 7, CD 2.82, and angle CAB 50 degrees. Calculate two decimal places the length BC. Considering BC, the length BC, we are finding this BC. So we have one angle, we have on the opposite two sides, and then we have to find the opposite side. So BC squared, we use cosine rule. So BC squared, so we have two sides and an included angle. When we have two sides and an included angle, angle 50, we can find the opposite angle too by using cosine rule. So cosine rule, so this side, let's call it A. So A squared is equals to B squared plus C squared minus 2BC. Then substitute, we get 36 plus 64, 100 minus 61.71 square roots, we get 6.19 centimeters. So this side becomes 6.19 centimeters. And the size of angle ABC, locate angle ABC, ABC, we are finding this angle here. If we study this diagram, we have opposite angle to side to the angle, and then we have another opposite side to this angle. So we are given two sides and an included angle because we have worked out for BC. So we have two sides and one of the two sides and one angle. So we can use sine rule. So we say A over sine A is equals to B over sine B. 6.19 over sine 50 is equals to 6 over sine B. Cross multiply, we get the angle as sine B is equals to 0.74. The sine inverse of this one gives us 47.95. The size of angle CAD, still we can see we have two sides, 7 and 6. We want this angle, and we have one side. So when we are given three sides and one angle, we can use cosine rule. So we say a squared plus d squared minus d. Then we substitute. We have the value of a, 2.82 squared is equals to 6 squared, 7 squared minus 2 times 6 times 7, and this one gives us, and working out, finally we get cosine of a, which is 0.91723. The cos inverse gives us 23.48. Our last equation, area of triangle ACD. Triangle ACD, we have this angle which we have worked out to be 23.48. We have three sides. We can decide to use the different formula. We have AB sine theta because we have two sides and an included angle. So we say half AB sine theta, half times 7 times 6, because we had this angle as 23.48. We have this side 2.82. We have this one 60 centimeters and 7 centimeters. Two sides and an included angle. So we work out a half times 8 times 6 times 7, then sine of an included angle, which gives us the area of 8.367. Question, the last question, question 15, a question on length of a belt. Two pulleys of radii 21 centimeters and 10.5 centimeters have their centers at A and B 40 centimeters apart. A tight belt runs all around the pulleys as shown in the diagram. Calculate the length of belts in contact with the pulleys center B. So center B, our length of belt will move in contact will be length of an arc. So we need this angle. For us to find this angle, we should, this angle here will be the same as this one, because this line should be parallel to this one, so will act as a transversal. Then if we draw this line, we want to get a rectangle, and we know that in a rectangle opposite sides are equal, so this one will be 10.5. 21 minus 10.5 will remain still with 10.5. This one is a right angle triangle. There's a right angle triangle at ANB. So we want this side, or we can find, and if we want the angle, we can use 10.5 as the adjacent and 40 as hypotenuse, so that we have this right angled triangle where this is 10.5, this is 40, and the shorter side that we don't know, we want this angle, so we choose cosine. So we say cosine of 10.5 or 40, cosine of this is equals to 74.78. You multiply by 2, because what we get as 74.78, this side also it is 74.78, multiply by 2. Length of an arc is equals to theta over 362 pi r. Using the same, we get length of an arc as 27.42. Then we have length of belt in contact with the pulley center A. In center A, it is this length that we are finding from here all the way to this one. So it is still length of an arc, but this time round the angle is the leaf flex angle. So to get that angle is 360 minus 149.56, which gives us 210.44. Length of an arc will be equals to theta over 362 pi r 210, and we work out with a radius of 21. We get 77.16. Total length of the belt. So we have this side as 27.42. We have also this length as 77.16. So what is remaining is on this side, and to get this side, it is the same as what we had here. This length is the same as this one. Using Pythagoras theorem, 40 squared minus 10.5 squared. This is 40 squared minus 10.5 squared. We get this length as 38. We get this length as 38.6, and because this one is 36.60 or 38, this one also would be 38.60. Now length of the belt would be the total distance all through. So we are going to add 38.6 times 2, 77.19, plus 77.19 plus 77.16 plus 27.42, and this one gives us so this arc, another arc, and then this length, this one is 38.6, 27.42, 77.16. So we sum them up, this times this one times 2, then we find as 181.77 as our distance and the length of the belt. This one marks the end of revision of section 2 mathematics form 3. I wish well in your studies. Bye.